Hello, everyone. This is Team 4 in CS6604 class, Spatial Data Management. So this video is to show the demo of our course project. In recent years, it's becoming increasingly popular in ride-on-demand services for its convenience. However, the dynamic price and waiting time are creating concerns for passengers, keeping them from making decisions easily. In this project, we perform dynamic price prediction based on multiple source urban data, such as the specific date and the specific hour of the day when the ride happens. We will use regression models and time series-based prediction models to effectively estimate different variables that affect Uber price and waiting time. This is the overview of our proposed recommendation system. So basically, we first collect ride trips and store them in ride trip database. Second, we also crawl route status data and store them into route status database. These two databases will be indexed using both spatial index and temporal index. Users can interact with the system interface to visualize the route. And also user can enter a trip query. Then the system will return a Google map with recommended schedule and price. So now I will show you how our recommendation system works. So there are two buttons, history and query, representing two interfaces. So basically the history interface is just to tell users how Uber actually works, because it's built based on ground truth data that we collected from Uber. So as you can see, we focused on, so this interface, we focused on 10 departure locations and one destination, which is North Virginia Center, Virginia Tech. And you can choose departure time during this time period, because the data was collected from 23rd November to December 1st. And you can choose any car type from 13 available car types. Here, request a map. So this basically will tell you how Uber will provide you options. So ETA represents the estimated waiting time, which is about 4 minutes, and the price is about $70. And here the blue dot represents the current location of the driver. The right dot represents the departure location. The yellow dot represents the destination. And this is the history interface. And now the query interface is where a user will make a query. So similarly, it has mostly a similar set of functionalities. You can specify departure time and destination, and you can start the trip on weekdays and weekends from 10 a.m. to 10 p.m. And the car type, you can specify any car type, and this user preference will be a parameter which balance the trip price and the waiting time. So basically, if you want a cheaper trip, you should specify this value larger, and lambda user preference ranges from 0 to 1, so you should specify larger, say 0.9, and then you request a trip. So now this is how our recommendation system responds. The estimated price is about $70, and the estimated waiting time is a bit long. And the best departure time is 10 a.m. And also you can request the map just to get a sense of the locations and the location of the current driver. And also you can specify different types of maps. So we have plane map, terrain map, and satellite maps. Now we can choose another location and say we want to start the trip at night. So basically the recommendation system recommended the best, the top ranked trip that are available. It's about $27, and the waiting time is a bit long. And the best departure time is 7 p.m. And here you can find the same set of information. So this is how our recommendation system is like. Thank you.